This video is scripted and edited and written by Nehor Dash. This video is scripted and edited and written by Nehor Dash. 17 branches of mathematics and their definitions, which is written by Nehor Dash for public domain purpose only. Mathematics is a formal science in which we often use letters, symbols, and signs. It is derived from the Greek mathema, which can be translated as study of a subject. It also makes us able to solve problems. Arithmetic, algebra, analysis of functions, geometry, statistics, and probability are some important branches of mathematics. Before going to dig deeper into branches of mathematics, let's have a bit of introduction to mathematics. What is mathematics? Before we dig deeper into branches of mathematics, the queen of sciences, let's have a brief introduction to mathematics. Mathematics is the science of numbers and their operations, interrelations, combinations, generalizations, and abstractions, and of space configurations and their structure, measurement, transformations, and generalizations. Source: what are the main branches of mathematics? With the immense and rapid progress in science, there is a variety of branches and sub-branches is found in mathematics. However, there are 17 major branches divisions which are given by Nehor Dash for public domain purpose only. 1. Geometry. 1. Geometry. 1. Geometry. Geometry is another important branch of mathematics that deals with the study of figures in space and their links in different dimensions, generally 2 or 3. It also studies the relationships between points, lines, and other figures. Geometry can be divided into two further branches such as trigonometry and descriptive geometry. It helps to solve the triangles and complex numbers. We often discuss many other things in trigonometry like vectors, planes, and lines, etc. Try also, types of triangles. 2. Algebra. 2. Algebra. 2. Algebra is a branch of mathematics that is dedicated to analyzing different structures and studies a combination of elements, operations with polynomials, equations, inequalities, and systems of equations. It also relates to performing arithmetic operations through letters or symbols, matrices, determinants, and linear programming. What is algebra? Try also, difference between parabola and hyperbola. 3. Arithmetic. 3. Arithmetic. 3. Arithmetic. Arithmetics focuses on understanding and study of numbers and their different operations with integers, rational, irrational, real, and complex numbers, powers, radicals, and logarithms, etc. Furthermore, it deals with the elementary operations of addition, subtraction, division, and multiplication. It is considered the basic branch of mathematics from which other branches spread out. What is arithmetic sequence? Try also, types of angles. 4. Trigonometry. 4. Trigonometry. 4. Trigonometry. Mathematics concerned with specific functions of angles and their application to calculations. There are 6 functions of an angle commonly used in trigonometry. Their names and abbreviations are sine, sin, cosine, cos, tangent, tan, cotangent, cot, secant, sec, and cosecant, CSC. These 6 trigonometric functions in relation to a right triangle are displayed in the figure. For example, the triangle contains an angle A, and the ratio of the side opposite to A and the side opposite to the right angle, the hypotenuse, is called the sine of A, or sin A. The other trigonometry functions are defined similarly. These functions are properties of the angle A independent of the size of the triangle, and calculated values were tabulated for many angles before computers made trigonometry tables obsolete. Trigonometric functions are used in obtaining unknown angles and distances from known or measured angles in geometric figures. 5. Infinitesimal calculus. 5. Infinitesimal calculus. 5. Infinitesimal calculus. The infinitesimal calculus, or calculus of infinitesimals, constitutes a very important part of modern mathematics. It's normal, just call it calculus. Calculus, as an algorithm developed in the field of mathematics, includes the study of limits, derivatives, integrals, and infinite series. Specifically, The infinitesimal calculus is the study of change, in the same way that geometry is the study of space. The infinitesimal calculus is a first-rate scientific and technological tool, undoubtedly the most powerful and efficient for the study of nature that mathematicians have ever developed. What makes it so versatile is the great variety of processes of all kinds: mathematical, physical, technological, economic, biological, which are modeled and solved using the infinitesimal calculus. Paraphrasing Galileo, it can be said that infinitesimal calculus is the language of nature. However, few people know the great versatility of the basic concepts of calculus, the derivative and the integral. The infinitesimal calculus or calculus of infinitesimals constitutes a very important part of mathematics that studies concepts such as functions, limits, derivatives, integrals, infinite series. It is very common in the academic context, for convenience, simply call it calculus. More specifically, infinitesimal calculus is the study of change, in the same way that geometry is the study of space. The infinitesimal calculus has wide applications in science and engineering and allows us to solve those problems for which algebra alone is insufficient. The infinitesimal calculus includes two main fields: differential calculus and integral calculus, which are related to the fundamental theorem of calculus. In more advanced mathematics, calculus is usually called mathematical analysis, or simply analysis, and is defined as the study of functions. Try also, types of numbers in math. 6. Mathematical analysis. 6. Mathematical analysis. 6. Mathematical analysis. Mathematical analysis is a branch of mathematics. This focuses on the study of real and complex numbers, as well as their representation, even using letters. Mathematical analysis, in particular, addresses topics such as derivatives, integrals, limits, series, and various types of complex functions. The purpose of mathematical analysis is to solve complex calculations through abstraction. To do this, it uses tools such as functions. Mathematical analysis is an area of mathematics that studies the behavior of real numbers, which are the basis on which part of the analysis in mathematics, and complex numbers. It also covers the constructions obtained from these numbers, such as functions, series, sequences, continuity, limits, and convergence, as well as the branches of integration and derivability. 7. Mathematical logic. 7. Mathematical logic. 7. Mathematical logic. The mathematical logic analyzes certain propositions seeking to identify whether it represents a true or false statement. At first, logic was linked to philosophy, having been initiated by Aristotle, 384–322 BC, who was based on the theory of the syllogism, that is, on valid arguments. In mathematical logic, we use propositional calculus, which resembles traditional mathematical calculus. As with mathematical calculations, in logic, there are some symbols and concepts that are fundamental for understanding and solving exercises. The reasoning we use can be classified as propositional calculus. An initial idea of logic is to classify something as true or false. Suppose a friend told you that a pear is a fruit. 8. Game theory. 8. Game theory. 8. Game theory. Game theory is a branch of economics that studies the decisions in which, for an individual to be successful, he has to take into account the decisions made by the rest of the agents that intervene in the situation. Game theory as a mathematical study has not been used exclusively in economics, but in management, strategy, psychology, or even biology. Game theory is a branch of mathematics and economics that studies the choice of the optimal behavior of an individual when the costs and benefits of each option are not fixed in advance but depend on the choices of other individuals. 9. Discrete mathematics. 9. Discrete mathematics. 9. Discrete mathematics. Discrete mathematics corresponds to an area of mathematics that is responsible for studying the set of natural numbers. That is, the set of countable finite and infinite numbers where the elements can be counted separately, one by one. These sets are known as discrete sets. An example of these sets are integers, graphs, or logical expressions, and they are applied in different fields of science, mainly in computer science or computing. 10 graph theory. 10 graph theory. 10 graph theory. Graph theory is an extraordinary mix of history, culture, and solutions to complex problems from the world of mathematics. This theory seeks to visually represent sets of abstract data in the forms of nodes or vertices and the union or relationships that these can have with other nodes through edges. Thanks to this theory, great advances have been made in the analysis of large volumes of data. Today, graphs are a central part of an incredible number of solutions to complex problems. They are one of the fundamental components of social analytics, relationships between people, and more recently their properties have been used to increase efficiency in the fight against money laundering and bank fraud. 11 Number theory. 11 Number theory. 11 Number theory. Number theory is the branch of pure mathematics that studies the properties of numbers in general and integers in particular, as well as various problems derived from their study. It contains a considerable number of problems that could be understood by non-mathematicians. More generally, this field studies the problems that arise with the study of integers. As Jurgen Neukirch cites, number theory occupies an idealized position among mathematical disciplines analogous to that occupied by mathematics itself among the other sciences. The arithmetic term was also used to refer to number theory. This is a fairly old term, although not as popular as in the past. Hence number theory is often called high arithmetic, although the term has also fallen into disuse. This sense of the term arithmetic should not be confused with elementary arithmetic, or with the branch of logic that studies Peano's arithmetic as a formal system. Mathematicians who study number theory are called number theorists. 12 Topology. 12 Topology. 12 Topology. The term topology is used to identify an area of mathematics that studies continuity and other concepts originating from it. It is a specialization linked to the properties and characteristics that geometric bodies possess and that remain unaltered thanks to continuous changes, regardless of their size or appearance. It should be noted that the continuous functions of mathematics are those that, in the close points of the domain, experience small variations in the values. At a graphical level, these functions are usually able to be drawn without having to lift the pencil from the paper. If you have features that coincide and share the same coordinate location, boundaries, or nodes, the geodatabase topology can help you better manage your geographic data. Geodatabase topologies help ensure data integrity. Using a topology provides a mechanism to perform integrity checks on your data and helps you validate and maintain better representations of the features in your geodatabase. Additionally, topologies can be used to model spatial relationships between entities. In this way, you can perform various analytical operations, such as finding adjacent entities, using coincident boundaries between entities, and navigating connected entities. 13 Pure Mathematics. 13 Pure Mathematics. 13 Pure Mathematics. Pure mathematics is the study of mathematical structures and their deductive consequences. It includes pure abstractions, such as logic and set theory, which deals with concepts that cannot be directly observed or used in practice. Pure mathematics can't be seen or touched, but it will help you to solve problems in your life. Pure mathematics also helps people understand how things work around them by examining the logical steps to get from one answer to another answer. 14 Applied Mathematics. 14 Applied Mathematics. 14 Applied Mathematics. Applied mathematics is the branch of mathematics that deals with real-world applications. It makes use of established mathematical tools to solve new scientific and engineering problems arising in different areas of science, engineering, business, medicine, and other fields. Applied mathematics is a field that will help you understand how mathematicians are solving new problems in the modern world. If you want to know more about applied mathematicians, then this post will be perfect for you. 15 combinatorics 15 combinatorics 15 combinatorics Combinatory CS is a branch of mathematics that deals with the study of counting and combining discrete objects. Combinatorics mathematics can be applied to many different areas such as statistics, graph theory, abstract algebra, geometry, probability theory, and computing. A few examples of mathematical principles found in geometry are linear combinations, which tell us about the number of ways two or more lines intersect at a given point. Permutations, which show what we get when we select R out of n items where each item may only appear once. And combinations, which tell us how many ways there are to pick k things from an n item set where order 16 Experimental mathematics 16 Experimental mathematics 16 Experimental mathematics The mathematics that is not yet proven is experimental mathematics. This is because mathematicians are still in the process of discovering new knowledge about it. They don't know if these mathematics will be true or false, but they keep working on them to find out more information about them. 17 Order theory 17 Order theory 17 Order theory Order theory is a branch of mathematics that studies how to describe the order in which different objects are placed. It has applications in studying various areas such as physics, biology, and chemistry. The fundamental concepts of order theory include ordinal numbers, the natural numbers, well-ordered sets, sets with no member greater than any other, and cardinal numbers, the whole number system. One important theorem about cardinals is the well-ordering theorem, which states that all finite sets have the least element. We can think of it like this: if you had an infinite set with no greatest element, then there would be two members one could consider greater than the other, so at least one must be less.